In this lesson, we will study about the data type known as set. A set contains a collection of objects and it is not a sequence, meaning that there is no order of the objects inside it. We will explore set operations and the cases where we should use the set instead of some other collection or sequence. I am assuming that you are familiar with the basic set theory, like a set cannot have the repeated elements and the union, intersection and difference of the sets, and the concept of subset, superset and disjoint set, etc. A set is defined by specifying the elements in between the curly braces. Let's print the set. It displays the elements, but note that the order of the element is not same as what we specified while defining that. That is the first property of a set, that it does not have the order and hence it is a collection and not the sequence. Let's check if we add another element inside the set, will that be added at the end of the set or not? I will use the method add of the set class. You can see it was not added at the end of the set. Python uses the concept of hash tables at the backend for the elements of the set, and in the hash tables the order depends on the hash function used there, and that order might not be same as what we specify at the time of defining the set. So there is no index of the elements inside the set. This looks a downside of a set. That's true, but the advantage is that searching inside a set is faster than other sequences like list or tuples. And in many cases, we are not concerned with the order of the elements, and there we can use the sets. Line number 2, where we have added a new element inside the set, also shows that the set is mutable data type. Let's see if we can have some list as the element of the set. And we have the error. A set is mutable, but it can have only immutable elements inside it, because the mutable objects are unhashable and hence cannot be stored inside the set. You can search for the details of hashability by yourself, but it's not needed to continue with set. So instead of a list, if we have a tuple as element of a set, we have no error this time. A set cannot have repeating elements. So let's define a set and have duplicate value as 45. You can see the good thing is that it does not generate the error, but 45 is present inside the set only once. The repeating elements are not stored in the set, and that is quite helpful as we will see shortly. Now let's define an empty set as a blank curly braces. Let's print the data type of A, and it is printed as dictionary. So we cannot define an empty set like this, because same curly braces are used for the dictionary as well, and to define an empty set, we should use the set constructor. Of course, we can use this constructor to create the set from other data types. Now I am defining a list here. See, that list has a few repeating elements inside it. If I want to generate another list without the repeating elements inside that, I will have to write a logic for that, but a simple solution is that if I convert the list to a set, that will remove the duplicates by itself. And then I can convert that set back to a list to get the final result as a list. So in a very simple way, we have removed the duplicates from the list. However, the downside is that the order of the new list might not be same as of the original list, but in many cases we are not concerned with the order of the elements, and in that case this approach is simplest of all. Apparently, it looks like the final result is a sorted list, but let's add a couple of more elements. And now you can see it is not a sorted list. So we cannot decide about the order of the elements inside a set. We can use the in operator to check the membership of an element inside a set. And a set is iterable as well, so we can apply the for loop directly on the set. Let's see the methods in the set class. After the special methods, these are the methods which we can apply on set. A set is a mutable data type, and many of these methods can change the set on which we are applying that method. I'm defining a set, and now I'm defining another set as b equal to a. These will be the same objects in the memory, and we can see that by printing the memory location of these two sets. There is a set method named as add, which will add the provided element inside the set. We are adding 100 into the set B, but since set A is same as set B, so if we print set A, you will see 100 is added in there. Now if we don't want set A be changed this way, we can use the set method copy, which returns a new copy of the set. So now set A and B are two different objects in the memory, and now if we add something in set B, it will not change set A. See, the addresses of both sets are different. This is because of the mutability of the set, and you can find the detailed difference between mutable and immutable data types in one of the previous lessons, and it is given in the description. Let's explore few other set operations. I am defining two sets. There is a method named as intersection. We can apply that on a set and it will return the intersection of that set with the input argument. This will not change the original set but will return a new set. So I am assigning that to a new variable. These are sets A and B, and this is the intersection of the two. Suppose if I have another set as x, and in the intersection method, I can provide more than one sets as the input argument, and it will return the intersection of the set with all sets provided as input argument. The intersection of set A with set B and set x is an empty set. Let me place 10 in set x, and now the intersection is 10. Another good thing in this method is that as the input argument, we can provide some iterable other than set. So here I am providing a list as the input argument, and it will return a set as intersection of set A with the input list. If input argument is a tuple, we get the same result. The multiple inputs can be different iterables as well. The method intersection returns a new set as the intersection, and we have a method as intersection_update. This will find the intersection, and instead of returning that as a set, it will update the original set A as a result of the intersection. So depending upon our requirement, we can use simple intersection or intersection_update. Like intersection, we have a method union, which will return the union of the original set and the set or the other iterables provided as the input argument. This is union of set A and B. Again, we can have multiple input arguments, and those can be iterables of other data types. Just like intersection_update method, which updates the original set, we have the similar method for the union, but the name is not union_update and it is named as simple update. So it will find the union of set A with set B and the provided list, and the set A will get the value of the result. Now we have a method named as difference. It will find the difference of set A with set B, meaning the elements in set A which are not in set B. Again, we can have multiple input arguments and the iterables of some other data type. And once again, we have the method different_update, which will not return the result as a new set, but will update the original set. I hope you can easily verify that by yourself. The next function is symmetric_difference. The difference is the simple difference method, which returns the elements of set A which are not in set B. But the symmetric_difference method will return the elements of set A which are not in set B, and the elements of set B which are not in set A. This is the output of the difference method, and you can verify that these are the elements of set A not in set B, and this is the output of symmetric underscore difference, which also includes the elements of set B which are not in set A. And again we have the method that will change the original set for the symmetric difference, and it is symmetric underscore difference underscore update. Now let's see some typical uses of the sets in different scenarios. This is a program that takes in a password from the user, and we have to verify if the password is a strong password. A password is a strong password if it has at least one uppercase letter, one lowercase letter, one digit and one special character. So here we are iterating over the string password, and we are checking if the character are uppercase letter, lowercase letter or decimal number by using different string class methods. And for the special characters we have imported the module string, and in there we have a string variable with the name punctuation which has all special symbols or punctuation marks inside it. So we are checking the membership in that string. If all conditions are satisfied, we are printing the message accordingly. But there can be a better way for this. Like here we have the string of all uppercase letters available in the string module, and actually I can find the intersection of this string with the password, and if there is any uppercase letter in the password, the intersection will not be an empty set. Both password and the string from the string class are string data type, so we can convert one of those to set, and then we can apply the intersection method on it. We don't need to change the second string to a set. So we can apply the condition if the intersection is an empty set or not. If it is not an empty set, it means the first condition of having the uppercase letter is satisfied. We could also have the condition as length of the intersection is greater than 0, meaning that there is at least one element in the intersection. Likewise, we can have the check for the other conditions. Actually, I can check all conditions in one if statement and don't need those check variables. Anyways, let's check the output. I'm entering the password without any special character, and we get the correct output. Now the password meets all conditions and the output is correct. In first solution, we were using the for loop to get each string character inside the password, and now we are just applying the set methods without need of the for loop. Now let's see a couple of more set methods. There is a method is disjoint. It will return true if set A and set B are disjoint, meaning that there is no common element inside them. Like other set methods, let's see if we can have multiple input arguments and also the iterables of other data type. But we have error. So we cannot have more than one input arguments for this method, but that one argument can be iterable of other data type. Another method is subset. It will return true if set A is subset of set B, meaning that all elements of set A are inside set B. And we have the method is superset, which returns true when set A is superset of set B, meaning all elements of set B are in set A. We also have some operators which we can apply on two sets. For example, this vertical bar, also known as the pipe symbol, is used for the union between two sets. This ampersand operator will find the intersection between two sets, minus will find the difference, this caret symbol is for the symmetric difference. All these will return a new set. Then we have the comparison operators as well. Equality will check if the two sets are equal. This less than will check if a set is subset of the other set or not, and greater than will check if a set is superset of other set or not. I will show you the use of just two of these operations. To find union, I will use the pipe operator. Let's see if we can have the second operand as of some other data type, as we have the case in different set methods. But we get the error this time. So the two operands must be of set data type for these operators. Now let's see one operator from these comparison operators. A less than B should return true because A is subset of B. So this was all about the set and the different set operations. Now I will show you two cases where using the set is very easy. Suppose that we have a grid world of size 5 by 5. The cells inside the grid are specified as row and the column from 0 to 4. Now suppose we have two robots placed on two corners of this grid. These robots can move in the grid and can scan a cell to get some information on the cell. Maybe the color of that cell, or maybe presence of some metal inside a cell with some sensor, or anything you could imagine. Suppose the robot on the top left corner follows this path and scans the cells. On the other hand, the second robot follows this path. If I show you the paths followed by both robots, this will be the situation. Now we are interested to know which cells have not been scanned by any of the robot, or the cells which got scanned by both of the robots, or maybe the cells which are not scanned by any of the robot. Let's see that. Here I have created the grid world as a list of two-valued tuples. Let's see that. And these are the cells inside the list from 00 to 44. And these are the cells scanned by each of the robot. To find the cells which are scanned by both of the robots, instead of applying some lengthy logic using the list, I can take the union of these two lists, of course by converting one to a set, and then can change the result set to a list. So this is the list of all cells which got scanned by any of the robot. Now I want to find the cells which were left unscanned by both of the robots. For that I can take the difference of all grid cells with the list of the scanned cells. I can use the subtract operator or the difference method. And these are the cells which left unscanned. We could also do it by subtracting the robot 1 and robot 2 path from the complete grid. Now I am interested to find the cells which were scanned by both robots, and for that I can use the intersection method. So you can see these set methods can be quite useful in different scenarios. I will show you one last such case. Here I am defining a list. Suppose I am interested to find the second largest value in the list, which for this case is 20. A simple method can be sorting the list and then picking the second last element, which is at the index -2. This returns 20. Now suppose if there is one more 33 in the list, this will return 33 this time. But if I am interested to get the second largest value as a different value from the largest value, meaning all same values should be considered as one value, then with list I will have to write some lengthy logic. And the easiest approach here will be converting the list A to a set, and that will remove all duplicates. And the built-in sorted function returns a list as output from which we are picking the second last value, and this time we get the value 20. Now the last thing I will show is the set comprehension, as we have list comprehension in case of list. Suppose I want to generate a set with the values as squares of all numbers from 1 to 20. I can start with an empty set, then I will generate the numbers 1 to 20. And inside the for loop, I will add the square of the loop variable I. We get this result. Now using the set comprehension, I can start with the curly braces and the expression will be I into I followed by the for loop. It's exactly like what we have in case of list comprehension, just the square brackets are changed to curly braces. The variety of cases we discussed in list comprehension are applicable on set comprehension, and of course I will not discuss those again here. You can watch that lesson for the other details of the comprehension. So that's all from this lesson. Thanks for watching.